What about warping, particularly with polymers? Why is it warping the material when it's been printed? Does it stick to the bed sometimes?
Well, it might stick to the bed, but of course it then cools and shrinks. The thermal expansion and hence contraction of polymers is very high. It's about 10 times as high as a metal, for example, which is nearly 10 times as high itself as a ceramic. So you've got a big differential in expansion contraction between, say, the glass bed that you're making the model on and the model material itself, and differential shrinkage that tends to lead to warping, especially when plastic products are fairly thin wall, thin shell type things. They warp fairly easily.
Would you say that if you bring the nozzle temperature and the TG temperature, if you can reduce that differential between the two as much as possible, then that would reduce warping and shrinkage? Or not?
When you say reduce the TG temperature, do you mean the bed temperature?
Well, you keep the bed temperature, whatever it needs to be near TG, but maybe you choose a material or design a material where the nozzle temperature or the melting temperature at printing is close to the TG, so the differential between these two figures is small. Would that help with shrinkage?
Well, it should reduce the shrinkage, but it might cause you other problems. I don't think it would flow back so well.
How important are melting points, and why is there a big range within polymers? Why are they not the same, all the same, like water boils at 100 degrees, for example? Why are plastic?
Well, water boils at 100 degrees, but it doesn't when you put salt in it. It boils over 100. Plastics are full of lots of things, not least of which the molecules themselves are not all the same length. So the longer molecules have a higher melting point than the shorter molecules. And polymer melting points are not single points, they're quite broad anyway. It could be over a 10 or more degree range that it actually melts. If you take something like water or a metal or whatever, it melts at a very sharp temperature. 1 degree below it and it's solid, 1 degree above it and it's liquid. Polymers have broader melting points than that. And they're not all the same, because obviously the structures of polymers are not all the same.
Why do you have to adjust your settings in a printer?
Well, to get the optimum performance, you need to adjust the settings to get the right, for example, the right temperature of the bed and also of the heated nozzle as well. Again, because these materials have different softening temperatures and different solidification temperatures, like TG or crystallization, then you've got to optimize that. It's normal practice for any material really to optimize the temperature. You don't cook a pizza at the same temperature that you bake a cake.